Yes, good morning, grade 12. Yeah, this is Patrick Kamala. Yeah, this is a combo for multiple choice questions or the trials 2025. Let us see how they get their answers so that you can prepare for November 2025. Thank you. Let us start. Yes, and so we start with this Eastern Cape 2025 trial. That is question 1.1. It says that a student throws a basketball vertically upwards into the air. She catches the ball 10 seconds later at the same height from which she threw it. Which one of the following statements is incorrect with regards to the above situation? So we're saying here that a student throws a basketball. Let's say she or he throws it in from this position here, okay? And then the ball goes up maximum height, then comes back, and then she catches it at the same level where she threw it from. So here, please understand from our theory that when the ball is moving in the air, the velocity keeps on decreasing. Maybe if the beginning velocity is 10 meters per second upwards, it's going to keep on decreasing from 10, then 9, 8, 5, 7, until maximum height here where velocity is 0 here. Then after being 0 now, at maximum height there, now it's going to increase from 0, 0, 1, 2, 4, 9, and then 10 again here. But the difference is that the velocity here at the last point here, it's now facing downwards, okay? So note it's the same 10, but downwards. Here it was 10, but upwards, okay? So what we know about this now, they say that which of the following statements is incorrect? Incorrect, not the English here. They say the velocity of the ball decreases as it moves up. That is correct. Then they say the velocity of the ball is 0 when at maximum height. That is also correct. Okay. Then the ball returns to the student's hand with the same speed with which she threw the ball. That is also correct. Why? Speed is the magnitude of velocity. You see, it is 10 here. Also, it was also 10 here altogether. Then they say part D. The acceleration of the ball as it goes upwards is equal to the acceleration of the ball as it falls downwards, but in the opposite direction. Now, this statement here is correct from the beginning, okay? It's correct from the start, like this, until here, okay? Now, the acceleration of the ball is as it goes upwards is the same downwards and the upwards. But the wrong thing is that it's not in the opposite what? Direction. That's not correct. Why? Because if you add this ball one more time, as it goes up, the acceleration is downwards, like this vertical downwards, okay? With that maximum height downwards, you see. So because it is always downwards, okay, it's never in the opposite direction. Okay? So that's why the answer is going to be D here. The answer is D because acceleration is the same and in the same direction. Okay. Let us proceed. 1.2. Question 1.2 Eastern Cape. Say here that when the car is at a constant velocity, it means that the elastic force acting on the car is 0. This phenomenon is best explained by, okay, so when a car moves at a constant velocity, it means that the net force acting on the car is 0. Then they say, how can you best explain this? Now we know that because the car is moving, okay, and we know our F net equals to mass times acceleration, okay, and they're saying at a constant velocity. Now because of this constant velocity here, it means that acceleration is going to be 0 because acceleration is changing the velocity. Okay, so v final minus v initial, if they're the same, that's constant velocity, so which gives us 0, the acceleration. So we're going to get 0 times m, which gives us 0, and so the net force equals to 0. And in that particular case, this is Newton's second law of motion, and because of that, our best answer going to be Newton's second law of motion. Okay, let us proceed here. Question 1.3 from from Eastern Cape. The diagram below shows a compressed spring between two trolleys, initially at rest on a horizontal frictionless surface. Trolley A has a mass of 2 kg and the trolley B has a mass of 1 kg. The string holds the trolleys together. They say the spring is cut and the trolleys move apart. In a comparison to the magnitude of the force the spring exerts on trolley A, the magnitude of the force the string exerts on trolley B is. Now I repeat, the diagram below shows a compressed spring between two trolleys, initially at rest, and on a horizontal frictionless base. Trolley A has a mass of 2 kg and the trolley B has a mass of what? Of 1 kg. A string holds the trolleys together, but it is compressed, so there is a force exerted by the string on trolley A and the trolley B. Now they say here that the spring is cut and the trolleys move apart, and they say that in a comparison to the magnitude of the force the spring exerts on trolley A, the magnitude of the force the spring exerts on trolley B is. Now here, we are going to use Newton's third law of motion. If body A exerts a force on body B, then body B will exert the same force on body A of the same magnitude but in the opposite direction. So for that matter, it will not be half, it won't be twice, but it's going to be the same. Why? Newton's third law of motion. Okay, let us continue here. 1.4. They say here that the two masses MA and MB are placed. This is MA here. This is MB. Are placed at a distance r apart. This is r apart. That's from A to B. And they said that a third mass MC, okay, experiences a zero resultant horizontal gravitational force when it is placed 3/4 radius from MA. That means from MA to MC to 3/4 here on the line between MA and MB. Okay. So they say the ratio of the two masses MA and MB are. Now I repeat, the two masses MA and MB are placed at a distance r apart. A third mass MC, this one here, experiences a zero. Note that. Experience what? A zero. Experience zero. Resultant horizontal gravitational what? Gravitational force. Okay. And then they say when it is placed 3/4 radius. Okay. 3/4 radius. So they say that now what is important here to note that the resultant horizontal gravitational force is what? Is zero. All together. And where is it placed? 3/4 from A, and there's going to be a quarter from B. They say the ratio of the two masses. Okay. Now this mass C is experiencing a zero gravitational horizontal force because the force of gravity, okay, the force of gravity on the mass C by B, okay, I'm gonna write like this. The force of gravity, the force of attraction, gravitational acceleration on C by mass what? By mass B is equal to the gravitational force of attraction altogether again on C, okay, on C by what? By A. So we're looking for the masses. So here we go. What do we know from our theory? That if the bodies are for any two bodies in the universe, there is a force of attraction, gravitational, which is what? Directly proportional to the product of the masses and inversely proportional to what? To the square of distance between their centers. And so here we go. I'm gonna say in that case that the gravitational force, okay, of attraction on C by A is equal to that same force on C by what? By mass B. Okay. But how do we know? How do we find that? We use G, mass of C times mass of A. Now distance from C to A, we check it here. They gave us 3/4. Okay. That's 0.75, 0.75, and R, but must be squared, squared here. And then what about this side? Also, mass of gravitational constant G times the mass of C, then times the mass of B divided by distance. If this is 3/4, what's the balance here? It's going to be a quarter. It's going to be now 0.25. That's a quarter. 0.25 r what again here. So we're talking about the ratio of MA to MB. So now, as you can see, the G is going to cancel out here and here, and the MC is going to cancel because it is the same here. And then here, I'm looking for MA to MB. So this is the mass I'm looking for, divided by this one here. So I'm going to say that the mass of A, okay, divided by mass of B equals like I'm going to cross multiply. I'm going to say the mass of A, okay, divided by the mass of B equals to this one. I multiply it up here. It's going to be now the 0.75, okay, r bracket squared, right? And then divided by what? 0.25, 0.25. This one here also r what? R squared, okay? Now, if I open my brackets here, I'm going to have 0.75 squared multiplied by r squared, divided by 0.25 squared multiplied also by what? By r squared. So the r squares, they are cancelled out here. And then with the calculator here, this one here gives us, if you look at the calculator here, you can take it out there. MA divided by MB. What do you get there, guys? Here I'm getting 9. I'm getting 9. So it's 9 here. But because I'm talking about a ratio, it's going to be 9 divided by 1. So our answer is going to be MA to MB is going to be 9 to 1. So the answer is D. So the answer is D. And I hope we are together. Let us proceed with our Eastern Cape multiple choice question 1. And now this is question 1 point what? 1.5. They say here that an object moves in a straight line on a rough horizontal surface. If the net work done on the object is 0, then what? The object moves at a constant speed. The object has 0 kinetic energy. The object moves with a constant acceleration. There is no frictional force acting on the object. An object moves in a straight line on a rough horizontal surface. Okay, they say if the net work done on the object is what? Is 0. Are we together? So what do we do here? You're talking about a rough surface, ne? So there's frictional force. Are we together? And then we have the applied force, okay? And I said that the net work done is what? Is 0. Okay, so for that matter, let us find out here our work done by the non-conservative forces, or you can even say work net actually. Work net equal to change in EK, okay? Change in EK. And then the work net is going to be the applied force altogether. I'm going to call it F applied minus what? Frictional force because it's moving, okay? Equals to a half what? A half M V final squared minus V initial squared, okay? So now because there is a zero network done, it means that in this particular case, for this one, for me to get a 0 here this side, it means V final should be the same as what? V initial. And for them to be the same, then that must be what? The same speed or same velocity. And so the answer should be this one here, constant speed. Now, the answer is A. We can say it is 0 kinetic energy because it is moving. That's not correct. And then so they're saying moving with a constant acceleration. This is not correct because they said we are having a 0 what? Work done, and this one is not accelerating to get 0. And they say no friction, not correct because the surface is rough. So the answer is what? The answer is A. Hope we are together, guys. 1.6 here. 1.6. They say the siren of an ambulance traveling down a straight road at a constant speed emits sound waves of frequency 700 Hz. A man sitting next to the road notices that the frequency of pitch of the sound changes as the ambulance moves towards him. Which one of the following frequency versus time graph best shows the frequency of the sound observed had by the man? I repeat, the siren of an ambulance traveling down a straight road at a constant speed emits sound waves of frequency 700 Hz. A man sitting next to the road notices that the frequency of the sound changes as the ambulance moves towards him. They say which one of the frequencies versus time graph best shows the frequency of the sound observed by the man. Okay, now what do we notice here? What do we notice here, and what do we know from our theory? Okay, they said that um, okay, the siren of an ambulance traveling down a straight road at a constant speed emits sound waves of frequency 700. A man sitting next to the road notices that the frequency of sound changes as the ambulance moves towards him. This is important to note here. As the ambulance moves towards him, the ambulance moves towards him. Okay. Now I think you've been somewhere and then the ambulance was approaching you. So from our theory, guys, note that we have got two types of graphs here. We have types of graphs, okay? I'll do like this now. Now, if this is the frequency, this side, which is of the listener, frequency observed, if the ambulance is approaching you, okay, um, when it's approaching you, okay, it's gonna be having if now this is 700 here. They're talking about here, 700 here, okay. If the ambulance is approaching you, we're gonna have a higher frequency. Are you together? We're gonna have what? A higher frequency like this. And then when it reaches where you are seated or standing, and then it bypasses you, then now the frequency is gonna decrease suddenly, and now it's gonna be lower. So this is the graph which we know from our theory. Okay. So in this particular case, it is approaching. Then maybe at this time t1, it is passing the main. So now here the frequency is higher, here it's lower. Okay. So for this matter, our answer is not this is C here, because you see this one is interesting. So the answer is what? The answer is going to be this D, because you see it is above the 700. Okay, as it is approaching him. So the answer is what? The answer is D. All right. Hope you get it now here. So here it is approaching. Here it is moving away. Okay. So the answer is D here. Let us continue. Next question here from Eastern Cape. That is 1.7. They said that here the three small identical spheres x, y, and z are charged as shown in the diagram below. The distance between sphere x and the z is h. I repeat, the three small identical spheres x, y, and z are charged as shown in the diagram below. The distance between sphere y and z is what? Is h. Okay. So this is x, this is y, this is z here. This is h between there. This is 16, -4, and then +4. They say the sphere y, this one in between, to experience a zero resultant force. The distance between x and y must be. Now note that again this is 0, which means it's not moving to the left or moving to the right. So meaning what to us? That this force, okay, of attraction on sphere y by z, okay, this force of attraction what on sphere y by z is on here should be equal to the force of attraction, okay, force of attraction on same sphere y by what? By sphere x. This one here now, okay, this one here now, which I'm gonna put in a green color. Now this arrow, it shows the force of attraction of sphere x on sphere what? On sphere y. Because they said it is horizontal, it is a 0. They said it's what? It's a 0. So being a 0, guys, it means that these forces must be equal, otherwise it will be moving. So what you're going to do here now, I'm going to say that the force of attraction on sphere y, okay, by z should be equal to the force of attraction on sphere y by what? By x. We know from Coulomb's law that this force is given by what? By K. I'm starting from this side. By K, and then times the charge on sphere Y, that is Qi, times the charge on sphere X, that is Qx here, divided by the distance from X to Y. I'm going to call it D squared, okay? But we see it will be equal to the force, again, from Coulomb's law, between Y and Z, that's going to be K times the charge on Y, are we together? Times the charge on what? Charge on Z, okay? Divided by the distance, in this case, they call it H squared here. So if you see here, I'm looking, the question says that the distance between X and Y must be, now that's the distance I'm talking about here, this distance is from X to Y. No? So from here, if you see in my mathematics here, I can see that the K is going to cancel out. And then also the charge on Y will cancel out because here's on both sides here. So in other words, I have got now the charge on X, are we together? The charge on X, which is what? Which is 16 microcoulombs, okay? That's 10 power negative what? Negative 6, okay? Divided by the D distance D, which I'm looking for, D squared here, should equal to the charge on Z, which is, that is 4 microcoulombs, net times 10 power negative 6 as well, divided by H squared, net, divided by H squared. So here, if I do cross multiply here, I can see that actually if I cross multiply, the power negative are going to cancel out, right? They can cancel out here. So if I cross multiply here, I'm going to have the 4d squared, the 4d squared, the 4d squared, right, equals to this 16 times h squared, that is 16h what? 16h squared. I'm looking for d, so divided by 4, I'm going to get my d squared equals to 4h squared. So then square root here. I'm going to get my answer for distance d as 2 what? As 2h. And so for that matter, our answer here, you can see it is going to be A. Hope we are together, guys. Let us proceed. Let us proceed here. Next question here, multiple choice, Eastern Cape. Point 8. They said that in the circuit diagrams shown below, all resistors and the cells are identical. So here we have one resistor, but this is equal to this one here. If this is 2 ohms, it's going to be 2 ohms and 2 ohms here. And then the ammeter here is reading the current here, and the voltmeter here. And this now difference here that these two are in parallel. You only have one resistor. And then they say here that which one of the following gives the correct comparison between the voltmeter and the ammeter readings? P and Q. P and Q. Now they say that cells are identical together with the resistors. Mean that if the voltage here, let's say, is 6 volts, okay, will be the same for the other one as well. What's other cell here? Okay, so take note of this, guys. They said that they are identical, right? They said they are identical, and so for that matter, they said the resistors and the cells, they are identical. So if this one we have got 12 here, it's gonna be 12 for this one as well. It's gonna be what? 12 for this one as well. So I'm gonna put my 12 here, same there. They said it's identical. Now note that because I only have one cell all together. Now the V here, okay. Let me start with the ammeter reading. Now this current here, let me say this is 2 ohms here, and here this is 2 ohms, and this is 2 ohms here. Now note that if resistors are in parallel like this, they have got a lower total resistance than this one here. For example, here it's gonna be 2 times 2 divided by 2 plus 2, which gives us 4 over 4, which gives us 1 ohm. So in here, the effective resistance is going to be 1 ohm. Now the 1 ohm being lower than the 2 ohms, it means the ammeter reading in Q will be greater than in P. So I start from there. So ammeter reading in what? in P is going to be lower than the one for what? For Q. So I look at my alternatives here. I say that I'm set because of the lower resistance here, we know that the current and resistance they are inversely proportional. So for that matter, the current passing here is going to be more. So the ammeter reading in Q is going to be what? Greater than the one in what? Than the one in P. So if I check here, in Q bigger than the one in P. So it means I'm going to choose from these options here. I'm going to choose from these options here. I see that our ammeter at Q, okay, is what? Is bigger than P. So here it is correct here. Where it's not correct, I'm talking about the ammeter reading. Ne? What about here? Here it is correct. Okay. So then now when I come this side now, this side is not correct. Ne? Now I'm gonna choose from B and what? From B and D. Now note that here, because we have the same cells, they have the same internal resistance, right? And because these two are in parallel, the V total is the same as V parallel. And here, because I have one resistor, which is the 2 ohms, which means this V will be the same as the V for the cell because I only have one resistor. So they're going to have the same what? The same potential difference. And for that matter, our answer here for this question from Eastern Cape, which is the question point 8, is going to be D. It's going to be D here. Okay, so the answer is D. The answer is D. Hope we are together. Let's continue here. Our next question here, they said that two strong magnets, two strong magnet bars are arranged with the north and the south poles facing each other, as shown in the diagram below. A current carrying conductor carries conventional current into the plane of the paper, is placed between the poles of the two magnets. Okay, they say the conductor will experience a force towards. It's a current carrying conductor, and at the moment we have this X here, like they're saying here, if you see with this X, this cross, ne, like this, okay, this cross like this, then our current is getting the paper. If they showed a dot like this, it will be coming out of the paper. Okay. Now, guys, the current carrying conductor, we use the left-hand rule, the Fleming's left-hand rule. So if I hold my finger here, and because I see this is north and then south, so my my second finger, the finger after the thumb, ne, is gonna be facing this way, okay, from north to south, okay, north to like this, and then because the current is getting to the paper, then my middle finger is gonna be getting inwards, okay, like it is getting inwards out together, and because of that, I can see here with my fingers that the thumb, it shows the force experienced by the conductor, and in that matter, it is upwards here, okay, it is R. It is R. I can see it here on my fingers. Okay, so the answer is what? It is C. You hold your fingers at 90 degrees to each other, whereby the first finger is from north to south, and then the middle finger is facing the paper you are holding right now, okay? And then where the thumb is going to be facing, in this case, it is facing where the R is. So that's where the conductor will move towards too. All right, then our last question here, 1.10 multiple choice. They say here that which one of the following graphs best represent the relation between maximum kinetic energy of the emitted photoelectrons and the intensity of an incident radiation? I repeat, which one of the following graphs best represents the relationship between the maximum kinetic energy of the emitted photoelectrons and the intensity of the incident radiation? Now, note guys that From our theory, please understand, don't forget this again. We know that the intensity of the incident radiation only increases the current, but not affect what? The kinetic energy. Hello? Does not affect what? The maximum kinetic energy of the photoelectrons, okay? And so, because of that, even if the intensity is increased, we're going to have the same kinetic energy. So the answer must be B. Maybe you can say that now, teacher, what changes the kinetic energy? It is only affected if you increase what? The frequency of the incident radiations. Are we together? What am I talking about here? If I was having frequency on the x-axis, then like you see for this case here, if this was frequency, if this was frequency, then this would be correct. It would be increasing, okay. But now because it is intensity, which only affects the current, but not kinetic energy, the answer is this one here. So the answer is B here. All right, that was Eastern Cape multiple choice. Yes, thank you so much. See you in our next paper. Yes, welcome back from that short break. Let's go to another province now. Multiple choice physics paper 1. This is now Free State, and this is question 1, multiple choice 2025 trial. Let us discuss how they got their answers. Okay. Now, one point on they said that when a book lies on a table, it moves because now the book lies on the table and does not move. They say the force exerted by the table on the book is equal to the force exerted by the earth on the book. Then say here, the force exerted by the table on the book is greater than the force exerted by the earth on the book. Then they say the forces acting on the book are in equilibrium. No forces are acting on the book. They are forces, but they are at equilibrium. So the answer here, which is best, is C. The best answer here is what is C. They are forces, but they are not at equilibrium. The answer is C. So the book will not move. Next question, they said that here that a maximum force of 8 Newton is exerted on the 6 kg block, which is at rest, okay, and just about to move. Just about to do what? Just about to move. And they said that on the rough surface, as shown in the diagram below. So they say that which of the following will increase the frictional force by the block? I repeat, a maximum force of 8 newtons is exerted on the 6 kg block, which is at rest and just about to move on the rough surface as shown in the diagram below. So this is the applied force, and the block is not moving, but it's just about to move. So they say, which one of the following will increase the frictional force experienced by the block? So they say here that if you do so, increase the applied force to 10 newtons. Now, because it is just about to move, this one will not increase that force. Okay. Then they say decrease the applied force. That one does not work. Then they say place a 2 kg block on top of the block. Now, this one is correct. This one is correct. Why? Because when you place a 2 kg block on it, then we're going to increase on the normal force. And frictional force is going to be another frictional force, okay, is proportional to what? To the coefficient times what? Times normal force. Okay, so if we increase on the weight, on the mass by adding another 2 kg block here, we're going to have increase in what? In the normal force. So the frictional force will do what? Will increase. So the answer is going to be what? C. Not just rotating the block. No. With the surface, it doesn't work. What is important here is the mass. The bigger the mass and the bigger the normal force, the bigger the frictional force. Okay, let us proceed here. 1 point. The acceleration due to gravity on the moon is G. Which one of the following represent the acceleration of gravity on the planet that is 3 times the mass and at the radius of the moon? I repeat, the acceleration due to gravity on the moon is G. Which one of the following represents the acceleration due to gravity on a planet which is 3 times the mass note here, 3 times the mass. And then they say also a third the radius of the moon, a third radius of the moon. Okay. So now note that from our formula sheet, our g, gravitational acceleration, is given by the universal constant g times the mass of the planet, in this case is the moon, by the radius squared from the center. Okay. Now they're saying that what about another planet? Okay, whereby they're changing the mass and the radius. So we still have the same g here, but then the mass is how many? They're saying 3 times mass of the moon. So it's going to be 3m, 3 mass of the moon. Okay. Now divide by a third radius of the moon. It's going to be radius of the moon. Okay. Divided by what? By 3, but must be squared. Okay, squared here. So for this matter, we're going to have this 3 give us a 3g of the moon, 3g mass of the moon divided by what? By r squared, then over what? Over what is 3 squared? It is 9. Now this 9, we know it's going to come and multiply the 3 here. So it's going to give us what? It's going to give us 27, okay, g mass of moon divided by r squared. And this case, we know that from here, what we see this one here is our what? Our original g from here, that is acceleration developed on the moon. And because of that, the 27 times g will give us the answer. In this case, going to be our b in this case here. I hope we are together. Let's proceed then here. Next, they say here that from free state, a body falls freely in the absence of air resistance, which physical quantity of the body is equal to the rate of change of momentum. A body falls freely in the absence of air resistance, which physical quantity of the body is equal to the rate of change of momentum. Now, the moment they say what is momentum? Now, we know momentum is momentum is given by mass times velocity. Momentum is what? Is mass times velocity. Now, the moment they say the change in momentum, we're having the change in momentum now, change in momentum here. It's going to be the change in mass and velocity, but the mass is constant. So mass, okay, times change in the velocity. But because they're talking about the way the rate, it means divided by change in time. So divided by change in time here. And when you do so this side, divided by change in time, what do we notice here? The change in the velocity of change in time gives us what? It gives us acceleration. So it's going to give us the mass times acceleration. But because it is falling freely, it's a free body. And acceleration, we know it is what? It is gravitational acceleration. So it's going to be the mass g, and we call it what here? We call it weight. We call it weight. So the answer is B here. 1.5 here, they said that a ball dropped from a learner's hand to the ground, which graph represents the kinetic energy versus velocity of the ball. Now, when the ball is being dropped from the learner's hand to the ground, and because it's being dropped, it's going to accelerate downwards by what? By g. Okay, by g. Okay. Now the acceleration, that g, it means increasing velocity. So because of we know that our ek is going by what? Ek equals to a half mass times velocity squared. So because of the increasing velocity, it means the ek must increase. So this is not correct. This is correct here. And because of the increasing velocity, it means it must not be this one. This one is constant velocity. It must be the one with the increasing gradient. And for that matter, the answer becomes A. Because with the A, you see the curve is increasing gradient. Because velocity is increasing, that set is accelerating at 9,80 meters per second squared. So the answer here is A for the EK versus velocity time graph. Okay. Then next question here. They say an astronomer on Earth observes light with wavelength lambda originating from a distant galaxy moving away from the Earth. The wavelength observed by the astronomer is likely to be, I repeat, An astronomer on Earth observes light with a wavelength lambda originating from a distant galaxy moving away from the Earth. Okay, the wavelength observed by the astronomer will be. Now, important point here is that it's moving away. It is what? Moving away. Now, because it's moving away from the Earth, from our theory, the moment it is moving away from the Earth, we know from Doppler's effect, that means it has got a decreasing frequency. It has got what? Decreasing frequency, which is observed. Okay. Now, if the frequency decreasing is what is observed, and we know frequency is inversely what? Proportional to the wavelength. Okay, so if the frequency decreases, then the wavelength must what? Must increase. And so for that matter, it's going to be greater than lambda. That's why it's A here. Okay. Because the object is moving away, you're going to experience a decrease in the frequency, which means the increase in wavelength because they are inversely proportional to each other. And so from Doppler's effect, it will be greater than lambda. Okay, let's continue here. Hope we are together, guys. Next here, they say that 1.7 from Pre-State 2025, they say here that consider the electric field patterns around the charged particles Q, R, and S as shown in the diagrams below. So this one is our Q, R, and S. They say what are the respective charges and the polarity on Q, R, and S. Now regarding the charges, we said we use a positive test charge. We use what? A positive test charge. So if we put it here, a positive test charge, okay, a positive test charge here, and as you see here, it means it's going this way, né? It's going this way, and because of that, it means that it's being repelled away, and this one being a positive test charge, then our Q must be what? This one must be positive. Are we together? And again, if we bring a positive test charge and put it here, now because here the arrow is pointing inwards, it means it's being attracted, né? Which means it must be a negative, attracting what? Attracting the positive test charge. So this must be a negative here. Then this one here, as you can see, the same story here. If we use a positive test charge again here, because the arrows are pointing inward, this must be negative as well. But however, that's not enough here. That's not enough here. We know that the more the number of the field lines around the charged object, I repeat, the more the number of the field lines around the charged object, the bigger the charge. Okay, the bigger the charge. So if you look at our S and R, although they are both what? They are both negative, but this way we have got more lines here, né? There are more lines, and here they are less, which means that the charge on R and the S, they're not equal, né? So the charge on S must be bigger than the charge on R. If you count all these on this, count this. If this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. What about here? If we say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So here there are 16 lines. Okay. Here there are only 8. Ne? Okay. So our charge here is double the charge here, but they are both negative. Okay. So mean that we're going to have our Q positive, negative, negative. Ne? So it could be what? It could be this one here. Our Q is positive, negative, and negative. Ne? But here, Q is positive, negative, and negative too. Now, this is the best answer here because the charge on S is 2 times the charge on R. So the answer is going to be C here. Okay, the rest are not correct. The answer is going to be that C there. 1.8 here. They said that the circuit diagram below has two identical resistors R and R2 and a battery with a potential difference of V. What's the potential difference across the resistor with the resistance R2? Now they're saying the resistors are identical, mean they have got the same Okay, meaning if this is 2 ohms, it's gonna be 2 ohms here. Okay, and because they are identical, they say what's potential difference across resistor R2, and because they're identical, they're gonna have the same resistance, or the potential difference and resistance. We know that potential difference and resistance, they are directly proportional. In other words, the bigger the potential difference, the bigger the resistance, the higher the difference. Ne? But because these ones are identical, they're going to share this one here, which is the total V total. They're going to share the V total equally. And so for that matter, the potential difference across resistor R2, like they're saying in here, okay, is be shared like this. You're gonna say that the V total, okay, the V total, you're gonna multiply it, okay, by the resistance of R2, and then divide by what? By the total resistance, because we are sharing equally. Okay, we are sharing equally. So for that matter, answer is going to be D. Okay, because the resistors are equal, they're gonna share the total resistance. Let us proceed then. Next question here, 1.9. The difference between a DC and AC generator is that a DC generator, by the way, this means direct current. What about AC? Alternating current. They say that is that the DC generator uses brushes for commutation, while an AC generator uses slip rings. Okay, they all have the brushes. That's not the answer here. I said that the DC produces unidirectional current, whereas AC denotes what? Alternating. Now, unidirectional means direction. So this is our answer here, because it has got what? It has got the same direction for the DC current, okay? That's meant by unidirectional, and then alternating for the AC, okay? They said that operates at a constant frequency. This is not correct. This is not correct here. And then they said that produces lower, that's also not correct, okay? So the answer here is B, whereby the DC produces a unidirectional current, meaning in the same direction, and the AC generates what? Alternating current. Then 1.10 here, they said that the number of photoelectrons emitted by the incident light of frequency f, which is higher than the threshold frequency f naught, is proportional to threshold frequency, frequency of light, intensity of light, then f minus f naught. I repeat, the number of photoelectrons emitted by an incident light of frequency f, which is higher than the threshold frequency f naught, is proportional to. Now look here, guys. If the question was saying that the number of photoelectrons emitted by a of frequency, okay, of frequency f together, and then they want us to say it depends on what, without saying higher than threshold frequency, then the photons would depend on the what? On the frequency of light. Do not, the higher the frequency of light, you're going to be more than threshold frequency, and so will be more what? More photoelectrons. But because there is addition here, they're saying that and the frequency which is higher than threshold frequency, okay, which means now we go a step ahead. So being higher than threshold frequency, if you want to get more photoelectrons, then now we must increase on the intensity of the light. So the best answer here is going to be this one here. It's not B, because B would be correct if the frequency was not what? Well, they didn't say that it was big or higher than threshold frequency, but because it is higher than threshold frequency now, that's not now a what? A reason anymore, but instead now we talk about the what? The higher the intensity, okay? We're gonna need what? We're gonna need why we're gonna get more photo electrons. I repeat, the number of photoelectrons emitted by incident light of frequency f, which is higher than threshold frequency, is proportional to what? to the what? To the intensity of light. Because the more the intensity of light, don't forget that each photoelectron kicks out one is kicked out by one photon. So the more the photons, the more the intensity of light, and the more the photoelectrons. That's why the answer here is what is intensity. And with that, don't forget, we said that for instance, Cape, that if the frequency is increased, you're gonna have the higher kinetic energy of the photoelectrons. I hope we are together. Let us proceed. Yes, you are welcome now to Limpopo. This multiple choice from Limpopo. Let us find out why the Limpopo people know their physics. Multiple choice question one here. They say which one of the following statement regarding kinetic friction is true. Now, kinetic friction is given by what? By Fk equals to coefficient, okay, times F normal. So they say here is what? Proportional to the normal force. So this is true, you see. This coefficient, actually the answer here is D, because if they say is equal to normal force and frictional, that's not correct. They is subject to being a D, that's not correct here, because we don't know if they mean they're not equal to the normal force, and they're not just equal, but you must multiply normal times what? Times coefficient. Actually the normal is the frictional force is proportional to the kinetic coefficient, okay? And then they're saying if that's proportional to the normal, that's not correct because we see directly proportional. So they say depending on the surface area, that's not correct because it depends on normal force. So the answer here is D. I repeat, I said that which one of the following statements regarding kinetic friction is true? You're saying the answer is what? It is directly proportional to the normal force on the object. Okay. Okay, next they said that 1.2 here. The gravitational acceleration on the surface of the Earth is G. Gravitational acceleration on another planet whose mass is 4 times and radius 2 times that of the Earth is, I think we saw this already in the one from the free state. Okay, so our G is given by the G times mass of the Earth divided by what? By radius of the Earth squared. But now our new planet talked about here is now they say that the mass is what? The mass is 4 times, going to be now 4 times m, the mass of the planet Earth, divided by what about the radius? I think 2 times the radius going to be 2 times the radius of the Earth here, but don't forget to square here. Now when you square it, you get a 4, and this 4 here, it gives us a 4 as well. So 4 g mass of the Earth divided by again 4 r squared. You can see here that the 4 is going to cancel here, and then if you check carefully, we see here that also here the gm over r squared is the same as the one which is we know before. So in other words, this g prime will be equal to this other g here, on which we already know. So the answer is going to be, it is B here. Okay, that is from Limpopo 1.2. And then they say here 1.1 Limpopo. They say that an object is dropped from the height h above the ground and the negative effects of air resistance. Which one of the following sketch graphs best represent the relationship between its kinetic energy and its height above the ground? I think we saw the previous one. It was Ek and the what and the velocity, whereby it was increasing gradiently. Now here talking about Ek, the height h. Now mechanical energy is the speed, it's a constant, right? It's a constant, okay? So if we happen to draw, note this guys, if you happen to draw the energy together, the energy here, and then you put the height here together, understand that in this particular case, the E mechanical is somewhere here, E mechanical somewhere here, it's a constant. Okay. Now, when the height is 0, what do we have there? When the height is 0, we have what? We have minimum potential energy. So this is for the potential height from 0. It was like this. This is the potential energy. That's EP. Okay. And then when the height is when the height is 0, we are gonna be when the what Yeah, when you drop something like this, okay, and then the height is 0 here, when it was coming down here, at the bottom is going to be the highest velocity, and so the highest kinetic energy. So it means EK would be what? Would be at maximum. Then it keeps on decreasing until the maximum point here. Okay. So in other words, at maximum height here, the EK is 0. Are we together? The EK is 0. And when the height is 0, the EK is maximum. So guys, this one is EK, this one is EK, this is EP. So our answer is going to be this one here. This is the EK, and you see it is decreasing like this, okay? Note that when the height is 0, the EK is maximum here. And yes, I hope it makes sense to you. This is EP. When the height is 0, the EP is 0. That's why EP begins from here and goes shooting up like that. 1.4, Limpopo 1.4. They say study the following sketch graph here. This is net force then versus time. Here they say that the area between the graph and axis is equal to what? Now, from what we see here, how do you find area of this triangle? It is the area equals to a half. Area equals to what? A half times base. Now the base here is changing time. Height, which is now what? Which is the F net, okay? Which is the net force here. But we know from our theory that the net force, F net, okay? F net equals to change in momentum divided by what? By change in time. But this time now, because we're multiplying the two, so our change in time comes here, and so this gives us change in momentum here. And in this case, our answer here is going to be A. The one between the two, between the graph and time axis, ne? So the answer is A. We see it from here by multiplying the change in time, that was the base, the height was here. Okay. Hope we are together, guys. Then again, Limpopo, question 1.5, they said that a body falls freely from rest after it has lost use of gravitational potential energy. Its speed is v meters per second. So the mass in kilograms of the body is equal to, repeat, they said that a body falls freely from rest after it has lost its use of gravitational potential energy. Its speed v its speed is v, then the mass in kg is equal to, now note that when the body falls freely, it is losing energy, at the same time gaining what? Kinetic energy. In other words, the potential energy E which has been lost is equal to the gained what? To the gained kinetic energy, okay? The kinetic energy. And how do you find the kinetic energy? Our E kinetic is given by 1 over 2, okay, 1 over 2, then mass of the body times velocity, what? Velocity squared. Okay, so we're looking for the mass, okay, the mass here. So multiply by 2, connect your 2e, okay, then equals to m what? Mv squared here. So looking for the mass, so divided by v squared, divided by v squared, divided by v squared. So mass in a kg is going to be the 2e over v squared, which you see it is here now, right? So it's going to be d here. Our answer here that from Limpopo trial 2025, that a listener is moving towards a stationary sound source. A sketch graph of the ratio F listener to F source versus V listener is shown below. They said that which one of the following combination gives the value of the intercept P and the gradient M of the graph correctly. Now, I hope guys remember in the class we said that when the listener is approaching a stationary sound source, meaning V source is going to be 0, then from Doppler, our F is equal to V, because the approach is going to be plus V, okay, V plus what? Plus the V of the listener, hey, my pen, come on, plus the listener, okay, and then divide by V minus V of the what? Of the source, okay, and then times frequency of the what? Of the source, okay. But because they're dividing it here, I'm gonna, okay, input it here for now. So if because I'm talking about the ratio here, which means on my y-axis this is f source, f listener by f what? F source. So if I divide by f source this side, guys, okay, you can see it's gonna cancel this side, f source here cancels out here. Now because it is a stationary sound source, I'm gonna have my f listener, okay, divided by F source, okay, equals to V altogether, then plus what? Plus V listener, okay, who is walking, okay, or moving towards the stationary sound source. So now V source is going to be 0, right? It's going to be 0 because it's stationary. So what is V minus 0? You get V. So divided by V here, both sides, everywhere divided by V. You can see that, guys. So in mathematics, I can say that I divide by V, okay, divide by V here, and divide by V here. Okay, so this one I can see that that one gives me 1, okay, plus what? I can say this V is a constant, so I can say 1 over V, the speed of V in I, and then times what? Times the V of the listener. So my ratio, which is F listener to F source, okay, to F source, I can see that if I compare in mathematics, I can say that this is my F actually over F source, okay, equals to 1 over V, and then times V what? V listener, okay, and then plus 1, okay. So it's of the form Y equals to M what? Mx, Mx plus C. Now in my question, what they did here, this guy, the intercept T, they call it P. So this is my P, and my P equals to 1, okay? And then the gradient M is M here. So my M, you can see, guys, my M is 1 over V. So here, it means that my answer is going to be A because the intercept is 1, which you see here already. And then the gradient is 1 over V, which you see here as well. So the answer is A. Hope, guys, we are together and you are still remembering what we talked about in class, okay? Then next question here, we're saying that the two charged particles in a vacuum exert electrostatic forces on each other. The system on the particles is changed in such a way that the force that the one particle, the other particle is 25% of the initial force. I repeat, I said that the two charged particles in a vacuum exert electrostatic forces on each other, and then they say the system is changed in such a way that the force that one particle exerts on other particle is now 25% of the initial force, so it has decreased. So this which one of the following statements best represent what happened during the process of transformation? So what have they changed here? We know that from Coulomb's law, that force, okay, equals to K times the charge, times the charge Q1, and then the other charge Q2, okay, divided by the distance squared, okay. So here, let's check here. Where can we get 25% of the initial force? They say here that when the charge on one of the particles is doubled, so if I put a 2Q1, I'm gonna double this one here, so it will be double force. That would be now 200%. That would be what? That would be now 200%. Okay, so I don't want that there because 1% is F. So to F we have 200%. Okay, now they say here the charge on the both is doubled. Now it's gonna be 2Q1, 2Q2 is gonna be now 4F. Now the 4F is not 25%. This is gonna be 4F, which is actually so it's 400%. But I want 25%, which means I want actually a quarter of the original force, because that's 25% means 1 over 4. Then if you look at C here, they say that the distance between the two charges is doubled. So if I take that now, if I double this one here, I'm going to have now my K, okay, times the initial charge Q1 times Q2 divided by double now, okay. Now if I square this, I can see that I'm going to get what is 2 squared going to be 4? It's going to be 1 over 4, and then times the K, okay, and then times the Q1, and then times Q2 divided by our R squared. Now, if you look here carefully, you can see that this one is the original force, which was F here, which was F before the changes were made. And so 1 over 4 is their quarter, which means 25%. And so for that matter, the answer is going to be C. Hope we are together. Answer is going to be C here. The next question here, they said that a hair dryer is rated 1200 watts. It is used for a total of 15 minutes if the cost of electricity is 40 cents watt hour. The total cost will be Okay, now this question, when we're approaching it, there's something I want you to look at here, guys. If you're looking for the total cost, you must know how much is 1 unit. Now, this unit, how is it measured? Beginning, they are saying kilowatt hours. Did you see that? This is a kilowatt hours. So the kilowatt hours mean that these watts here must be in kilos, beginning point. So the watts must be in what? In kilos. So the 1200 watts, put in kilos divided by what? And okay. And then, because this is kilowatt hours, these minutes must be hours, ne? So times what? The dividing by 60, changing from minutes to hours divided by 60 altogether. And then now, how much is that unit? Let's say it's costing how much? It is costing 340 cents. Okay, so times 3,40 times 3,40. Now, what do you get? Calculators? Calculators there. If I do mine here, it gives me 1,02. So the answer is A. The answer is A. That's what I get here. But I hope you know the logic now. First, get the kilowatts, get the hours, times the cost of that 1 unit, which is always given in the question. The next question here, which was 1.9, 1.944, they say here that the following sketch graph shows the change in the current in a generator. We need some space here. We need some space. Okay, so what we see on the y-axis, we have the current in amperes, okay, but you can see I've got positive and negative here. So this one is, it shows it is which type of generator. It's not a DC. This we said is a directional, so this one is going to be changing, and so we call it alternating current. And then from what we know here is that they're saying that they're saying here that they're saying that the following sketch graph shows the change in a current in a generator. Okay, so the one, is it an AC or a DC? Now, as you can see here, because of this one being it is showing the two cycles, né? So it means that this one must be C. So we're going to choose from this SC or this SC. Now, this one here is a complete cycle, because when I have one cycle like this, né, if I divide it into two, the one on top is 1/2, okay, and then the other one down here is the other half, né? So that is one cycle, and it's called a full rotation, né? So I'm gonna choose from A1 and A1, so from this one and this one, which means this one is now out, because it must be a complete rotation. Then the root mean square current. Now root mean square, you divide the peak. This is the peak here, which you also call I maximum. Divide I maximum by what? By √2. Now calculators divide by root, what you get? If you divide 1,3 by √2, what do you get there? Here I'm getting 0,92. So 0,92. If you check now, this is 1,3, which is not correct, and this is 0,9, which is, so the answer is going to be what? It's going to be B here. So 1,9 from Limpopo. That's how we answer it. It is an AC generator with one rotation and root mean square current of what? Of 0,92 amperes. Don't forget, guys, you must remember, or must revise definition of the root mean square current and √2 mean square voltage before it comes to you. Lastly, in our session, they're saying that the following two diagrams illustrate the simple differences between atomic absorption and spectra. We have energy here, spectrum A. Okay, this is the ground state from E node. This is E1. Spectrum B, have state. This one is E1. This is E2 here. We see they're saying that which one of the following combinations regarding the spectra is correct. They're saying we have got emission, absorption, emission, absorption. Then light frequencies, we have absorbed, emitted. Then spectrum B, they're saying we have absorption, this is B, this is A. We have absorption, emission. Then light frequency, they're saying emitted, absorbed, absorbed. Okay, so from here, let us look at spectrum A. Now, spectrum A, when you get from, you see this first arrow, when you get from the ground state and you are excited to energy E1, or from ground state and excited to energy E2, in that case, that you're absorbing energy, you're getting more energy. So it must be absorption. It must be what? Absorption. And because of that, you're going to choose from what? Where do you have absorption here? You're going to choose from this absorption all this. Then now they're saying light frequencies. Okay. Now, regarding light frequencies, we're saying here that because it is absorption here altogether, then it must be absorbed. It must be absorbing light frequencies. Okay. So it is this absorbed. Now this one being emitted is not correct there. Let's look at B, this other side here. Now on the side of B, because you're getting from higher energy level to lower energy level, okay, then that there we are emitting. So it's gonna be emission here and the emission here, okay? And when we if you look at what happens now, is that this arrow here shows that we are doing what? The light frequencies have been emitted. And so all the things come here. This one is saying absolutely not correct here. So the best answer here is going to be this one here. So the option is B for question 1.10 multiple choice Limpopo. Alright guys, thank you so much for watching. Catch you in our next video. This is Patrick Kamala, tutor, educator. This call science mathematics was Bye bye. See you in our question 2.